Today we're going to discuss BubbleSort. So in BubbleSort, we're going to always find the biggest element and we're going to move it towards the end. The way we're going to do it is we're going to start comparing every element with every other element which is next to it. And if they end up in a situation where the element on the left is bigger than the element on the right, we're going to move the element on the left to the right. So let's say we use a variable called current index. Here we're going to just write it as, well, I'm going to write it out anyway, current index. So let's say we're going to use current index of CI, and let's say our array of data elements has a value, of course, at current index, and if it happens to be greater than array of current index plus 1, then we're going to swap this with this, the values I mean, and with this. So for instance, a value something like, let's say we have 15 and greater than 7, then we will end up with 7, 15. So for example, let's say we have an input of 15, 7, and we're going to compare 15 with 7, and if 15 is greater than 7, we're going to swap. And that is the basic premises of BubbleSort. So let's apply this towards a data set and see how it works. Let's start with a sample input data of 6, 15, 2, 7, 3, and 1. Let me identify that in the index positions on the top like this. As we know, in computer programming, every index starts with 0. So we have 6 at 0th position, 15 at 1st position, and so on. So, like I said, we're going to compare every element with every element next to it. And if the element on the left is bigger than the element at the right, we're going to swap. So for example, if we're going to compare 6 with 15, as we know 6 is not greater than 15, we don't do any swap. We move on to the next position, which is position 1. And so we're going to compare the element at position 1, which is 15, with the element at position 2, which is 2. So as we know 15 is greater than 2, we're going to swap 2 and 15. So for our purposes, let's assume that we're going to keep track of our current index in a variable called CI. It's always going to point to the element on the left. Let me make points to on left. So we're going to write the index position we're trying to compare. In this scenario, it's 6. I'm going to do a little underlining of the current index just in case you missed it. So we're going to do compare 0 with whatever the value next to it. So the value at 0 is 6. So we're going to compare 6 with 15. So I'm going to draw a green arrow for comparison. We're comparing 6 with 15. So we're going to do comparison 6 with 15, 15, and obviously 6 is greater than 15, we're going to test. That is false. So this means we have no swap. We'll move now. We're going to increment our current index and move on to the next position. Just in case if we forgot, current index. So our CI is going to be 1, the value of 15. So let's write our array again, writing the indexes first. 0, 1, 2, 3, 4, 5. So 6, 15, 2, 7, 3, and 1. Let's scroll. So at this point, we're going to compare 15 with 2. So just like we did before, we're going to compare, we're going to write that comparing 15, 2. We're going to do this, 15 is greater than 2, and that is true. So this means we're going to swap 15, 2, which would, and we're, as usual, we're going to increment our CI. So the resultant would be, the result would be 0, 1, 2, 3, 4, 5. And just so to remember the elements, 6, 15, oh sorry, that is what we're swapping. We're swapping 15 with 2, so at this point we're going to have 2 here and 15 in position 2 and 7 and 3 and 1. As we always do, we're going to underline the current, where current index is pointing, and we are also going to write down what's our current index right here. So which is 2, has a value of 15. Now as you notice, 15, which was originally in position 1, moved 1 position to the right to position 2. So now let's repeat the process. We would be comparing the element at position 2, which is 15, with the element at position 3, which is 7, just like we mentioned earlier. So we're doing that comparison, and what do we end up with? Pretty obvious, but I'm going to write it out anyway. Comparing 15 with 7. So 15 is greater than 7, which is true. So here we go. If we are true, we swap it. Swap 15 with 7. And as usual, we are going to increment CI. No matter what. So this is what we'll end up with now. 0, 1, 2, 3, 4, and 5, which would have 6, 2, and this time 7 moves to 15, swapping 15 with 7, which would be 7, 15, 3, and 1. Our CI, which is incremented, would be pointing at this point to position 3, and which has a value of 15. All right, repeating the process now again. This time I'm not going to write that we're comparing what with what. I'm simply going to use the color to identify that we are comparing 15 at position 3 with 3 at position 4. So as we know, 15 is greater than 3, and this means true. This means we're going to swap 15 with 3, 15 with 3, and we're going to increment CI. So this is what we end up with. 0, 1, 2, 3, 4, 5, 6, 2, 7. One mistake. Let's three, 15, and 1. CI pointing to position 4 now, and which has a value of 15. As you notice, 15, which is the largest element, bubbled up with each step towards the end of the array, which is where we want because it's the biggest element. So now we're going to repeat this step again. We're going to compare 15 with 1, and we're going to write 15 greater than 1, true, which basically means we're going to swap 15 with 1, and I'm not going to, well, I'm going to write anyway, so just so we have it, increment CI. So this is what we'll end up with: 0, 1, 2, 3, 4, 5, 6, 2, 7, 3, 1, and 15, with our CI pointing to element 5, which has a value of 15. Well, now our largest element 15 has reached the end of the array, and that's where CI is pointing to. Well, now since CI reached end of array, we're going to identify that since 15 is already sorted and there's no need to move it anymore, we're going to identify the position 15 as the start of the sorted part of the array. So we're going to have another variable going forward, which is called, let's say, sorted part, sorted part lowest index, or lowest sorted, lowest sorted, which is going to be pointing to position 5. So we're going to say lowest sorted is equal to current index CI, which is position 5. So as you notice, we don't need to sort position 5 anymore, so we're going to identify that in a yellow color, and we're not going to bother with that in the next iteration. So this is the end of pass 1. So we're going to pass 2 at this point. We're going to do pass 2 start. So when we do start pass 2, we have to start again at the starting of the array. So our CI is once again set to 0. Our lowest sorted is equal to 5. So our CI has to sort all the elements starting from element position 0 till position 4. This is the unsorted part. So we're going to work on that now. So once again, we repeat our elements here. 0, 1, 2, 3, 4, 5. And I'm just writing 5 for the sake that we identify that we represent that in the array, but we're not going to bother. We're not going to do anything with it because obviously 15 is where it's need to be. So I'm going to use a yellow color to kind of identify that this guy need not be bothered. All right, or maybe perhaps I'm going to use an yellow color to draw a line here. Okay, all right, I'm not going to do it every time, but just remember it, guys, that's the sorted part. I'm going to write this. This is the sorted part, and our CI is 0. We're going to call our lowest sorted ls just for simplicity's sake. Ls is pointing to position 5. So our CI one has a value of 6, and we'll do what we've been always doing, which is we're going to compare 6 with position 2, and dot, and as you know 6 is greater than 2, we have a true. We will be swapping 6 and 2. So we would end up with array looking like this. So 6 to, oops, sorry, we just swapped that. So 2, 6, 7, 3, 1, and 15. Once again, I'm going to mark this guy as that. So our CI increments every time, is incremented every time. So our CI would be pointing to 1, and our lowest sorted index is pointing to position 5. So we would be, at this point, we would be comparing 6 with 7. And as you can see that 6 is smaller than 7. So this means no swap, and we would move on with our next iteration simply by this point. We're just going to increment our CI to 2. Our ls is pointing to 5, which is the lowest sorted, in case you forgot. So index is pointing to 5, and we would at this point compare 7, which is where our current index is pointing, with 3. 2, 6, 7, 3, 1, 15. Once again, 15 marks the barrier, and we'll be comparing 7 and 3. So what's the result, guys? I mean, what do you think? Well, 7 is greater than 3, which is true. So yeah, we have a swap. Swap 7 and 3. At this point, let's use the right color. This is what we'll end up with. 0, 1, 2, 3, 4, 5, 2, 6, 3, 7, 1, 15, current index would be as usual incremented and would be pointing to position 3. Hey, I forgot to write the value here. 7. Value 7. Our LSI, our lowest sorted index, is pointing to 5. So we moved 7 one position to the right. So basically 7 bubbled up one position towards the end of the array, and it's one short position from being where we want it to be. So we would be comparing 7 with 1, and for obvious reasons we'll be swapping 7 greater than 1, which is true, and we have a swap. Let me erase this. Swap 7 and 1. So this point, this is what we'll end up with. 2, 3, 4, 5, 2, 6, 3, 1, 7, 15, which marks our border. Oops, yeah, but you get the idea. CI has a value of 4, value is equal to 7, and our LS is pointing to 5. And as we know, we don't want to, there is no point in comparing position, the value at position 4 with the value at position 5, because we know the value at position 5, which is what LS is pointing to, is already sorted. So we will stop our sort here and we're going to upgrade our LS. Since CI is LS minus 1, nothing left, sort 7, and then we're going to upgrade our LS to CI, which is going to be 4. So there we go. That marks the end of pass 2. Over, and we're going to be doing our pass 3 start. Okay, so with that demonstrated, we're going to put our markers again. 2, 6, 3, 1, 7, 15, and this marks our sort pod, and this is our unsorted pod. Now our CI is obviously reset to 0, value of 2, and we have our ls now pointing to position 4. So we're going to compare two with 6. So since 2 is greater than, since when we do our 2 is greater than 6, which is false, so which means we have no swap. And we're going to continue with our next iteration, which basically means CI would be pointing to position 1, as with every iteration CI gets incremented, which has a value of 6, and ls is pointing to position 4, and we're going to do 2, 3, 4, 5, 2, 6, 3, 1, 7, 15, and quickly identifying our sorted part. We're going to compare 6 with 3. 6 is greater than 3, true, which basically means we're going to do a swap. 6 and 3, and just in case you forget, we are going to also increment CI, so which basically means 0, 1, 2, 3, 4, 5. CI is pointing to position 2, value is going to be 6, ls is going to position 4 and 2, 3, 6, 1, 7, 15, and I'm going to try that. That's the sorted part. Now we would be comparing 6 with 1. Obviously 6 is greater than 1, 6 is greater than 1, that is true, so we have a swap. 6 and 1. Oops, don't know what happened, but at this point we would be, our CI would be at a position where it can't go any further, because guess what, we already reached the sorted part, which is 2, 3, 1, 6, 7, 15, and that's the sorted part. So our CI has a value of 3. Sorry, CI has a value, is pointing to position 3, which has a value of 6, and our ls is 4. Once again, since CI is equal to ls minus 1, go So ci is equal to, sorry, ls is equal to, at this point we're going to upgrade our ls to point to wherever ci is pointing to, which is 3. So there we go. That marks the end of pass 3. Pass 3 over. Pass 4 starts. Let's identify our indexes again. 2, 3, 4, 5. And what do we have here? 2, 2, 3, 1, 6, 7, 15. Alright, so if you guys can see, this part is already sorted. Everything to the right of this yellow line is sorted, and everything to the left is unsorted. Alright, so we just need to bother with the unsorted part, and our CI, once again, is reset to 0, has a value of 2, and our ls is pointing to position 3. So let's identify our position 2. We're going to be comparing the value at position 0 with the value at position 1, which is basically comparing 2 with 3. We're going to say is 2 greater than 3, which is false, so no swap. We're simply going to increment ci, and which basically means leads us to the next one, step 0, 1, 2, 3, 4, 5, and that would be 2, 3, 1, 6, 7, 15. Define that, and CI is pointing at this point to position 1, which is this, has a value of 3, and ELS is pointing to 3. Now we're going to compare the value at position 1, which is 3, with the value at position 2, which is 1, obviously. So that will be 3 is 3 greater than 1, of course, so that's true. So this will end up with swap 3 and 1, and there we go. And we're going to do the obvious increment CI. So this is what we'll end up with: 0, 1, 2, 3, 4, 5, 2, 1, 3, 6, 7, 15. Our CI pointing to position 2 with the value of 3, ls pointing to position 3, and let's just identify the sorted and unsorted parts. Everything towards the right of the yellow line is sorted, everything towards the left is unsorted, is what we're working on. And since CI is equal to ls minus 1, there's nothing else to sort. We're going to do set our ls to what CI is, which is going to be 2, and we're going to reset the CI to 0. So that is, let's see, pass 4, right? So we're going to mark that pass 4 is over. Pass 5, start. Once again, 0, 1, 2, 3, 4, 5, 2, 1, 3, 6, 7, 15, and since our lowest sorted index is 2, draw our yellow line here, and we're going to say everything here is sorted. This is the unsorted part. You must have noticed the unsorted part has sunk as we progress, and our CI is 0 once again, value of 2, ls keeps encroaching more and more towards the left, which is now pointing to 2. Oh boy. So we are going to compare, hold on, let me mark, this is the current index is pointing to, and we are going to be comparing that with the value at the next position, so which is 2 greater than 1, true, and we will swap 2 and 1. So obviously, and we're of course going to increment CI as always in this algorithm. So we'll end up with something like this: 0, 1, 2, 3, 4, 5, and 1, 2, 3, 6, 7, and 15. CI pointing to position 1, the value of 2, which is this guy, then ls pointing to 2, and let's draw our wall. That's it. So at this point, since CI is equal to ls minus 1, which is 1, nothing left, sort, and I mean at this point ls is equal to CI, which is equal to 1, and since there's nothing left to sort, and since ls is equal to 1, which basically means sorted, there is nothing left. Nothing left. So let's write our final result: 0, 1, 2, 3, 4, 5, 1, 2, 3, 6, 7, 15, and let's identify what is the sorted part. So since we always made sure that the biggest element ends up towards the end, the only element which should be left in the first position would be the smallest element, and there is no need to sort. So that's the result. Thank you guys.